You know what? हाल की बड़ी सुनामी ताजा जानकारी 2025 रूस काम झटका 30 जुलाई 2025 विशाल भूकंप सुनामी 30 जुलाई 2025 रूस के काम झटका प्रायद्वीप के तट के पास 8.8 तीव्रता का भूकंप आया। भूकंप उथला था लगभग 20 किलोमीटर गहरा है इसलिए इसने एक और बड़े सुनामी उत्पन्न की। आमचटका और पूरे द्वीप समूह के तटीय इलाकों में 3-4 मीटर ऊंची लहरें दर्ज की गईं। सेवेरो कुरिल्स नामक शहर में बंदरगाह डूब गया, नौकाएं बह गईं, कुछ इमारतें क्षतिग्रस्त हुईं। समय पर चेतावनी के कारण कोई बड़ी जनहानि। कई देशों में सुनामी चेतावनी। भूकंप इतना बड़ा था कि पूरे प्रशांत महासागर में चेतावनी जारी की गई। जापान करीब 19 से 20 लाख लोगों को तटीय क्षेत्रों में निकाला गया। एहतियातन कई न्यूक्लियर प्लांट्स को भी सुरक्षित मोड में रखा गया। अमेरिका, अलास्का, हवाई, वेस्ट कोस्ट तट पर छोटी-छोटी लहरें आई, नुकसान नहीं हुआ। लोगों को समुद्र से दूर रहने के निर्देश दिए गए। कनाडा, चिली, पेरू, फिलीपींस कई द्वीपीय देश हल्की लहरें यह सिर्फ चेतावनी स्तर के संकेत। नुकसान कम क्यों? अर्ली वार्निंग सिस्टम तेजी से काम कर गया। रूस और जापान के में लोग सुरक्षित स्थानों पर पहुंच गए। प्रभावित क्षेत्रों में जनसंख्या कम थी, इसलिए जोखिम कम रहा। भूकंप के बाद कई 6 से 7 तीव्रता के आफ्टरशॉक्स भी आए, लेकिन सुनामी का खतरा नियंत्रित रहा। हाल ही के अन्य भूकंप सुनामी का खतरा है। इंडोनेशिया 27 नवंबर 2025 6.3 तीव्रता का झटका, सुनामी का कोई खतरा नहीं। अलास्का 27 नवंबर 2025 6 तीव्रता का भूकंप, सुनामी की कोई चेतावनी नहीं। You know what? 30 July location coast of Kamchatka Peninsula, Russia. Science behind this tsunami. No, why quake create a large tsunami? Mega thrust earthquake, most powerful earthquakes on Earth. This one caused massive vertical displacement of the sea. Sudden upward push of the water column. Tsunami waves radiating outward. Massive vertical displacement, seafloor, sudden upward push, water column, tsunami waves radiating outward 700-800 km per hour. Depth ruptures the details. Depth 20 to 21 km varies to allow. Rupture the length estimated 350 to 400 km. Rupture width 60 to 90 km. So allow quakes. With a large rupture surface generate strongest tsunamis. Tsunami wave travel timeline. Kamchatka, Russia 15-20 minutes. Kuril Islands 35-45 minutes. Japan, Hokkaido, Honshu 2-3 hours. Hawaii 7 hours. Alaska 5-6 hours. California, USA 8-9 hours. South America, Chile, Peru 13 to 15 hours. Tsunami lost energy as it is spread out, which is why faraway regions saw smaller waves. Impact in Russia. Epicenter area. Most affected cities. Severo, Kurilis, port heavily flooded. Fishing boat destroyed. Warehouses, coastal factories damaged, some residential areas flooded, water entered up to 300 to 500 meters inland in some zones. Infrastructure damage, partial collapse, port buildings, airport runway cracks, power outages, roads blocked due to the flooding or debris. Casualties. Official report indicate no major deaths thanks quick evacuation. Japan. 2 million evacuated, bullet trains suspended, hundreds flights delayed, coastal nuclear plant moved to emergency cooling mode, damage, minor flooding in Hokkaido, boats overturned in smaller harbors, some breakwaters overtopped by the waves, no major damage or casualties. United States, Hawaii, Alaska, West Coast, tsunami alarms activated island-wide, fringing reefs reduced the wave height, minor sea level rise in Waikiki, Hilo, and no flooding reported. Alaska, small tsunami recorded, fishing ports temporarily closed, and U.S. West Coast beaches closed 24 hours. Strong currents, harbors, no structural damage. Aftershock sequence, more than 40 aftershocks, 36 hours, 12 aftershocks above the M6.0, no largest M6.9. Some underwater landslides were suspected but did not generate the secondary tsunami. Satellite buoy data. Tsunami detections buoy across the Pacific recorded clear wave signatures. Wave period 10 to 25 minutes. Amplitudes near the epicenter 40 to 70 centimeter in the deep ocean. Satellite observed the sea surface elevation changes confirming tsunami propagation. Why this could have been much worse. Three crucial reasons: directions of maximum wave energy. Most energy travel toward the open ocean, not towards a densely populated city. Low population density. Many areas along the Kamchatka coast are remote. Rapid warning. Pacific tsunami warning center (PTWC) issue alerts within 3 minutes quick. Comparison with historical tsunamis, mega tsunamis. Kamchatka 2025 8.8, very few, and strong preparedness. Now Japan 2011 9.1, 20,000 deaths, massive flooding. Indian Ocean 2004 9.1, 2 lakh 30,000, no warning systems. Chile 2010 8.8, 500, severe coastal floodings. 2025 similar magnitude 2010 Chile, but far less destructive. Okay, let's do this. It isn't, but we can do more. Energy released by the earthquake 8.8 megathrust earthquake, enormous amount of energy. Energy comparison 8.8, 15,000 Hiroshima bomb worth energy equivalent 3 lakh tons. TNT 1 top 10 strongest earthquake ever recorded. Massive energy directly translates into the strong tsunami. Tsunami propagation, how waves travel across the Pacifics. Now, tsunami waves travel 700 to 800 km per hour deep ocean, fast jet airplane. Wave behavior, deep ocean, low weight, high speed, near source, speed reduces, height increases, soaring effects. Wave reflections, waves reflected off the Aleutian Island and redirected toward North America. Some energy reflected toward the Japan and Hawaii. Southbound energy decayed quickly due to the Pacific Basin curvature. Now 0 to 3 minute by minute timeline tsunamis. Countries highest risk during the event: high risk Russia, Kamchatka, Kuril Island; Japan, moderate risk Hawaii, Alaska, California, Oregon, Washington, Canada, British Columbia; low risk South America, Pacific Island nations, Southeast Asia, New Zealand. Did this tsunami affect India? No. India is the Indian Ocean, not the Pacific Ocean. Why India was safe? Tsunami energy step India inside the Pacific. No connection between the Pacific fault zone and the Indian Ocean basin. No wave propagation routes and towards the Bay of Bengal or Arabian Sea. India's tsunami risk zone general knowledge. Andaman Nicobar region, Makaran subduction zone near Pakistan, Iran, Sunda subduction zone, Indonesia. Could similar tsunami happen in the future? Yes, but rare. Highest risk regions globally. Japan, Kuril, Kamchatka Trench, Alaska, Latian, Subduction Zone, Chile, Peru Trench, Indonesia, Sunda Trench, and Solomon Island region. These are the world's most powerful earthquake zones. Earth for observation from satellite. Satellite Jason 3, Sentinel 6, HEMA, Wari 9 observed. Sea surface elevation changes. Wave patterns moving across the Pacific, real-time sea height modeling, confirmation tsunami arrival at the different coasts, and this data helps refine the global tsunami models. How early warning system worked so effectively. Systems involved Pacific Tsunami Warning Center USA, Japan Meteorology Agency, Russia Emergency Ministry, NOAA Dart Boys, IOC, UNESCO Tsunami Monitoring Network. Why they succeeded? Fast seismic detections, automatic modeling, and coastal alarms, public awareness, quick evacuation. This is considered one of the best handled global tsunami alerts recent history. Technical tsunami characteristics wave period 10 to 25 minutes typical major ocean tsunamis. Wave length 200 300 km between the wave crest and so the ship at the sea barely feel it. Deep ocean wave height only 40 to 70 centimeter but becomes 3 4 meter and when reaching the coast. If you want even more details. No scientific explanations like wave soaring, resonance effect, tsunami energy, decay, and subduction mechanics. How tsunami forms subduction mechanics. Clear step by step. Subduction zone setting. One tectonic plate dives beneath another along the megathrust fault Pacific plate under the Okhotsk plate. Stress build-up, plates lock, elastic strain accumulates over a decades, a century. Rupture when the fault ruptures suddenly, a large patch of the sea floor moves vertically, uplift or subsidence. Water column response: the vertical displacement of the sea floor instantaneously displaces the entire overlying water column. That displacement begins radiating away as a long period wave tsunami. Key factor controlling tsunami size: rupture, the length, amount of the vertical displacement, water depth above the rupture, and directly the direction of the rupture propagation. Waves soaring: why small deep ocean waves become the huge at the shore. In deep water, tsunami wave height is typically small and tens of centimeters, but the wave has enormous energy and a very long wavelength, hundreds of kilometers. As the wave approaches the shallow water, wave speed drops. C. Root GH wavelength shortens to conserve the energy. Wave and height increases. This amplification called soaring. Local bathymetry matters. Narrow the base continental cells underwater canyons can amplify the focus energy, producing the much larger runs-ups and specific supports. Example: zero point 0.5 meter deep ocean amplitude can become the several meters concave bay over the shallow self resonance and the harbor effect. So why do some harbors experience a huge oscillation? Harbor resonance: a harbor or bay has a natural oscillation periods. If the tsunami wave period matches the harbor natural period, strong resonance occurs, causing the prolonged slosing and amplified local amplitudes. Age amplification: harbors with the reflective walls and shallow basins or sieves that trap the energy can see the damage long after the first wave arrives. Multiple destructive surges and practical implications: some small harbors suffer worse damage than nearby open coast because of the reasons energy budget and the decay. How tsunami energy spreads and decreases. Total energy is set largely by the earthquake and moment size, and the amount of the vertical sea floor displacement, geometric and spreading. Energy spreads roughly with the distance along the circular front. Energy per unit length drops, so amplitude decays with distance. Frequency of dispersions, long period energy travel faster and farther with less attenuation than the short period energy. Bathymetric scattering and bottom frictions allow and the rough bottoms dissipate energy. Islands ridges allow cells scatter energies, creating the shadow zones and focusing zones. Net effects far-felt tsunami amplitudes drop, and but the local bathymetry and directivity can produce surprising the local high. Wave characteristic typical numbers you can expect with deep water speed 700 to the 900 km/h for ocean depth several thousand meters. Typical wave periods 5 to 60 minutes, commonly 10 to 25 minutes. Large event wavelength 100 to 400 km deep ocean amplitudes often less than 1 meter, but the content the large energy and coastal run-up depends on the local slope and shape from the tens of meter to greater than 10 seconds a meter in extreme local amplification detections modeling warning workflow how authorities act seismic detection seconds and global network detect earthquake locations magnitude USGS, JMA, and GFZ. The automatic tsunami assessment within the minutes. Initial modes use the earthquake parameters, tsunami propagation physics, estimate arrival times, amplitude, dart, and tide gauge. Deep ocean buoys, dart, and coastal tide gauge confirms actual sea level anomalies essential for refining the warnings. Satellite altimetry post-event confirms the sea surface elevation patterns, useful signs and post-event assessment, message disseminations, PTWC regional and the center issue watches, warning cancellation message, national authorities, media silence, mobile alerts, and local action, coastal evacuation, port and harbor closure, critical infrastructure shutdowns, nuclear plant precautions. Country by country, quick risk snapshots, high risk, Pacific risk, Japan, Hokkaido, Toku, Russia, Kamchatka, Kurils, and Alaska, Chile, Peru. They sit on active subduction trenches, moderate risk, Hawaii, US, West Coast, British Columbia. Some Pacific island depend on directivity and the Indian Ocean different basin main tsunami source for India Sunda Trench Indonesia Makaran Pakistan Iran local sources Andaman Nicobar Sumatra a Pacific event like Kamchatka generally does not produce damaging tsunamis in India. India practical point high risk of pockets Andaman Nicobar Eastern Bay Bengal coast part of the Gujarat and Karachi coast and Makaran influence. Low-lying delta Sundarbans extra vulnerability due to the sea level storm surge compounding Mediterranean capable local tsunami subductions, landslides, and generally smaller transoceanic reach. Now preparedness what actually reduces casualties early warning system and reliable dissemination sirens and SMS radio minutes counts, clear evacuation maps, and vertical evacuation structures. Horizontal evacuation is the possible impossible. Public drills education knowing the first wave may not be the largest to stay clear for hours. Harbor management small boats evacuate deep water when instructed not to stay in a port. Critical infrastructure planning place essential facilities above likely run-up elevations make them sea resistant. Local signage and trained community volunteers guide evacuations remote areas. Practical takeaways and if you feel along a strong earthquake near coast, immediately move higher ground inland. Do not wait official warning. Observe the natural signs and sudden sea threat retreat, and immediate danger signal. After the event, stay away from the shore at the least several hours and multiple waves can follow. Keep a small emergency kit and know the local evacuation routes and high points. Follow official channels, National Meteorological, PTWC, Pacific, false alarms safer than the missed alarms. Want academic visual and deliverables? No, let's. Okay, I think it's a good research work. A little bit more. It is nice. It is. Thanks to be here.